Check, check. All right, hey, welcome back, you guys. I've decided, this was intended to be this is going to be the third episode, was going to be the Z-axis. We did the X-axis, then we did the Y-axis. We're going to do the Z-axis, but I came across something when I was digging through these files, and I want to address that one first. So that's why we're going to use so hey, man, the guy who designed this, big ups to Scott 3D, again, went above and beyond what the normal RepRap person does. There's a kind of an attitude in RepRap of like, hey, man, I've done a little of the work, tough luck. You don't need me to hold your hand through it, and I like that, actually. It's reaffirming of that kind of like experience is the king type of attitude that dominates real makers. And but you know what? It doesn't hurt to kind of help people along when they're new. So look at this thing here. If you look in the folders for the Hypercube evolution that Scott 3D has shared with us, if we look here, there's an XLSX file. It says Hypercube evolution configuration. Now I don't. Now what that is that's an extension for Microsoft Excel spreadsheet, which does the calculations for you. You don't need to actually own that. What you can do is you take this and you upload it to Google Drive, which is completely free, and you can have it convert it, and it seems to work just fine in Google Drive, at least for what I've been doing. Okay, so let's take a look at this document that I have imported down. And if you need help doing that, there's a lot of guides on the internet on how to import spreadsheets into Google Drive and convert them and use them live. Okay, so if we look here, you're going to start on this sheet here, and this one doesn't seem to be as useful, at least for what I need right now. Basically, what I need to tell you is that I have been building it with the wrong dimensions. I was like, I just assumed, let's use 500 millimeter rods. Now, there's a good reason I'm probably going to end up doing that when I made my modified version. However, the whole point of making this on SketchUp before we go into something more advanced like Onshape or Fusion 360 is the kind of the idea that like you want to just get an idea of how things work together, and that's what we're going to do here. So we're going to actually build it true to what Scott 3D had intended. With the exception of like, the bed and some things like that. And there's some good reasons for that. All right, so look, 300 by 300 by 300. You can put these travel in here. And what you'll see, now I'm not going to change these for right now. I'm actually going to adjust it down to what his default settings were. Okay, because if you look here on X, if you change this, let's say that you just said, nah, man, I only want 250. Watch what happens. It will automatically update the data down here for how long you need to cut your extrusions and your shafts. So let's see what that changes. Okay, so now look down here and see what did that affect. So I'm going to undo it with Control Z. Okay, so it looks like if you follow this, it's changing the length of the shaft for the 8 millimeter shaft you use. Yeah. So see, that's how this thing works. We're going to go back to 300, right? So it changed also the extrusion length. And so what we're going to do is we're going to go through here. Those look fine for now. The only thing I'm going to change from his default is the MK2A heated bed. I think that's a terrible choice for this project. I would never use that. And the reason is because on the MK2A, the mount holes are all the way at the side. And if you look at the video he made on it, he had to actually add extra support to hold the middle up because it was so far cantilevered. It's probably not a good choice for this. I'm going to use a custom choice for my heated bed, and that information is just basically what this selects is which column are we pulling from. Are we pulling data from this one, or not a column, I guess it would be a row, or the custom. I want it on custom because what I'm going to do is I'm going to use a widely available, cheap CR10 heated bed. It's the one that people are using for the CR10. It's widely available, probably cheaper than that one, and a better choice because the mounting screws for it are actually further in. They're not all the way out at the edges, and so it reduces significantly the difference, the offset in these holes, which reduces the amount of sagging possible in the middle that Scott 3D himself admitted he experienced in his videos. So if you look at this, it's 310 by 310 for the external dimensions. Let's go put those in right now. So I'm going to put 310 by 310, and you'll notice nothing changes. It didn't affect any of these values down here. And later we'll learn why that is, which is why it's so valuable to build stuff in SketchUp before you actually do anything. Okay, if we look here, they're not 310 by 310 for the offset of the holes. It's actually, you have to take away 35, 35 on the other side. That's 70 total. 310 minus 70 gives us 240 offset between all the holes. So I'm going to go in here and put 240. And this should make some changes, 240. And so now this gives us, oh, and we didn't do one thing. Now look, here's another thing that's important to understand. So another configuration that we have to have is the bed brackets. And that's these. I'm going to use the minimum size possible because I don't want them cantilevered and hang out 45 millimeters from here to here. If you don't understand this fully, the side, if you look at the bed here, he's a cool little picture here, by the way. Another, just, man, that's killer. Like the fact that he has a picture of that, that's awesome. And it kind of explains what these dimensions mean is that I want to keep this offset and overhang of the bed screws as minimal as possible. So I'm going to use these bed brackets 15. Okay. And the other big deal is the shafts. So we're going to change that. I'm going to use 8mm shafts for the y-axis. I'm using the 10mm option. And the z-axis, you don't really have a choice. You just 12, tough luck. Now this part is important. If you're making the 300 by 300, I can tell you the whole reason that Scott 3D, I've watched through some of his videos, even made the double z-axis is because when he went to a 300 by 300 meter bed, what he found is the single one was too vibrational. Worked fine for the 200 by 200 millimeter version, but he found that it was much better performing with the double z-axis if you're using a 300 by 300 millimeter bed. Okay, so I'm going to go with a double z-axis there. Well, what am I talking about? Well, here's the difference. If we look at this, I hate the way that they did this. Yeah, Thingiverse is the way that they do their images now. Thingiverse is such an awful website. I mean, it's just, if it even works and loads all the time proper, even on good internet, it just doesn't. Ugh. Anyways, so look how hard it is to even download this. And part of that's probably my internet, and part of it is okay. Well, there we go. Okay, so let's take a look. This is the single axis version. It works pretty well for 200 by 200 millimeters, but the problem is it's cantilever. What that means is that essentially picture this as the back of the bed and this is the front. The bed kind of hangs out, and so it's only supported by the back. That's what this guy is right here. Okay. What he found is that when he went to a 300 by 300 millimeter bed, that overhang caused it to be very stable at the back where it was anchored by the 12 millimeter rods. But as Scott 3D moved to the front by his own admission, this started to kind of vibrate from the cantilever. Cantilever just means like an overhang design. So what he did was he basically copied it, where he took basically what was the z-axis and moved it to one side and copied that to the other opposite side, so it's held up by 4 12 millimeter rods and it's actuated by 2 lead screws or threaded rod, whatever you're going to use for that. And he found that this was much more sturdy, much more stable for the bigger 300 millimeter size. And you could even do this for the 200 by 200 millimeter version as well if you wanted to. Look, man, we're going to definitely be using this because 12 millimeter rods are very cheap compared to what they used to be on the market. Okay, so anyways, we're going to use the double z-axis version of that. So I'm going to select double z-axis, and you can look as we change single to double. That definitely changes these and changes like how many you need of each one. All right. Okay, so we have it 300 by 300 by 300, and my problem is when I made the first 2 videos, I did not follow these recommendations for length. I did it based on basically the shafts were all going to be 500 millimeters. And hey, man, there's a reason why I'm doing that. It's because if you've ever had to cut hardened chromed steel rods, they're not easy. You have to use an angle grinder or get a special blade for your chop saw. And I have those things, but most people don't. And it's not a fun experience. If you're not used to working with metal, it's not a fun experience to cut hardened chrome steel. It's just not. And so that's why I would not recommend using these values. But remember, we're building it the way he did it first, and then we're going to modify it later. Okay? With the exception of the bed, I cannot go any further using the bed that he used. I couldn't see any reason why I'm doing it because I'm never going to use that bed whatsoever. So anyways, let's go ahead and I'm going to move this over here because we need to reference these values down here quite a bit, I'd say. So let's move. Okay, that doesn't do it dynamically. And let's move over a little bit. We don't need to see that. And we can drag this one all the way over to here. So we'll have minimal interaction with this from here on out, but we will be able to see these values that we need. So all I'm doing in this video is I'm just going to update and adjust everything. And hey, man, this is useful because you're going to have to adjust your designs as you make them. So I've turned off perspective in the camera. That's turn it to parallel projection. By the way, whoops, God, I hate that. SketchUp will break from time to time, and you'll have to go back to seeing perspective. If you start rotating things and you see through halfway through objects, it glitches. Just do that. All right, so let's take a look and let's fix what we need to fix. First of all, let's get the extrusion lengths correct. X, Y, and Z. Now look, my Z is already, if you do a vertical measurement, you can see at the bottom right, down here, way over there, you can see that we did get to 500 millimeters. I don't need to fix anything for Z. Because I need to fix this one and this one, I'm going to move them, select them both, move them over here. And you know, all I'm doing is I'm exposing the ends. Because if I try to adjust them, I'm going to be pushing on these ends. Well, you'll see. Okay, now let's see. This one says that for the y-axis, let's see what I did. I think I did 500 millimeters. Okay, no. For the y-axis, it's going to be 410. All right. That means I have to get rid of 90 millimeters, but I'm going to do it evenly on each side, so it's 45 millimeters from this side. Whoops. Be careful of those little mini clicks that don't do what you want them to. Whoops. Is that right? 45. Okay. And I'm going to push it in 45 from this side. That way, things will be centered on the originals. And see, this is what's nice about SketchUp, is that these are components. So it updated all of these the same. I'm going to delete that. I don't need it anymore. Okay, this one. Let's see what I have. I have, for the x-axis, going across, mine's 470. I need to reduce that down to 420. So that's a difference of 50, but it's going to be evenly distributed on two sides. So I'm going to go 25 on this side and 25 on this side. So all we're doing is just kind of getting this to more the way that the original designer had intended. All right. Okay, looks pretty good. And so now we have all of our aluminum extrusions. They are not in the correct position. I'm going to wait till later to do that because there's a pretty cool shortcut that you can do to make this a little bit easier, I would say. Okay, what's else? Something else that's going to need to be adjusted. These belts. So let's move a copy. Oops. A copy of these belts here. I'm going to grab them all at once so we can just kind of do them all one copy. So I'm going to move it, control to make a copy, and move it out here. You see the glitching I was talking about? It's starting right now. So, okay. So let's go ahead into these. This was, the y-axis got shortened by 20, or x-axis 25 on each side, 25 here. And there's the glitching. And I don't know, maybe it's not. Maybe I'm just, maybe I don't know what I'm talking about, but okay, 25, done. Don't need those. This one, 45 on each side, because that's what we shortened the y-axis by just a minute ago. 45 here, and 45 here. This one, you know what? This one probably isn't even necessary because I realized that later on that this one doesn't really look right if we move the axis around, but let's just shorten it 45 on this side just for the heck of it. Okay, so that looks like things are ready to be moved around now. Oh, one other thing. These rods are significantly shorter, so let's move a copy out here. This got shortened up again. If we look at the rods now, the Y shaft is 45. Okay. Excuse me, 410, which means it's 45 shorter on one side, and also 45 shorter. Whoops. 45 shorter on the other. Cool. And get inside this group. Make a copy of this. $45. Did I say 45? Sorry, my bad. These were supposed to be shortened by 25. 25. Okay, cool. So now we have those shortened down, and here we are. The supposedly Core XY is compact and saves on space. This design does not bear that out. And I'm going to get into that later because that is a common thing that people parrot about Core XY. And I would say for the y-axis, that is correct. It is very space efficient for the y-axis. At least with the implementations that I'm seeing of it, it is not a space efficient, let me just repeat that. It is not by any stretch of imagination a space efficient design for the x-axis, period. Okay, and maybe I'll get into that later in other videos, but everybody says that. They like to say it all the time, but at least in the implementations that I've seen, the most popular implementation of Core XY is right in front of you. It is not a space efficient design, and we will get into that later, but you can see that all of this space, look at the wasted X-Rod space here. Look at this. This is all, not necessarily all wasted, because even if you did it more efficiently, you would still have to get rid of some of this. But look at this. This is 45 millimeters length. And let's say that you had to clamp it with 10 millimeters. That's 35 millimeters on one side alone. That's just a wasted X-Rod. And I'm going to get into this later. Like if you compare that to design, let's say Micro-Wrap 100 or 200 like the one I designed, is much more space efficient on the x-axis, but not nearly as space efficient as this on the y-axis. So you'll see that parroted all the time about Core XY. Do not believe it. It is not true. And it happens to do with the fact that no matter how you cut it, you have to have this extra wasted space from travel from the middle of the motor kind of out to the edge. And again, I'll get into that later, maybe in a later video. I'll have time to go over that with people. Doesn't mean Core XY is bad. It just means that one of the selling points that people parrot again and again and again has it's not valid. Simply put, it's not valid. Again, it's not bad, but I'm just saying this implementation in particular is not space efficient. Do not believe it. When people tell you it's space efficient, it is not. You are not getting the most, basically the smallest printer for the most amount of print area. You're not. Simply put, you're not. Not with this one. And the y-axis, like I said, I'm pretty impressed. It's pretty good. The x-axis does not hold up in court. Anyways, I'm kind of ranting on some stuff. So let's go ahead and get me off that rant. And let's get a top view. Okay, so let's get rid of this. This was one of our helpers. I'm just going to move around. So what I'm going to do is I'm going to explode. So these are broken into parts, and I'm just going to grab... Now, remember, selecting like this only grabs the stuff that's all the way inside of the box. Hey, that's it. That's what we need. And I can hear my dog scratching her collar there. We're going to move it in by 25 because that's what we shortened the x-axis by. And same thing over here. Nope, wrong selection. Sorry. There we go. And we're going to move this in by 25. And let's grab these guys, move them up by 45, because that's how much we shorten this by. So again, now we have something that looks a bit more like this. Now, hold on, there's some other things. If we look here, let's get back to this one, this picture here. So if you look here, check it out. This has another rod, another piece of aluminum extrusion down here. And so we're going to have to copy this. And after looking it up, I didn't know exactly how far to go. The offset here should be 130. So we just do another copy of this, 130. Move it down on the blue axis, 130. Probably should have grabbed the other one before I did that too, but I didn't, so let's do that again. And if you're using 48 millimeter motors like I plan to do, these are the larger steppers. A little more torquey, I guess you could say. These guys are barely going to fit. I think it came out to be 1.2 millimeters clearance there. Just keep that in mind if you're building the original. Okay, so we've got that done. What else did we need? I'm also, from this, I'm not exactly sure that these are correct. And I'm going to probably further align these when we line up the z-axis, because I wasn't able to find exactly where these go on the design. And there we go. And just to cap off that rant I went on earlier about Core XY not being a very space efficient platform in terms of the x-axis. And again, it's not a criticism too bad. It's just that some things work well and some things, other things don't. Let's take a look at that real quick. And just before, if you want to stop the video right now, go ahead. I could understand that. Let me just, so I don't mess with this too much, let's just make it a group. No. Yeah, make it a group. Move a copy over this way. Let's move it over 1 meter, 1,000. All right, so look, here's what I was talking about earlier in case you think I'm just a raving lunatic. So here's the problem with Core XY that other printers don't have quite as bad of an issue with. So I'm going to delete these so that we can kind of get a good look at the kinematics. Get rid of this, get rid of this. Okay. Get rid of this stupid frame. We don't need that. All right, so look, man. So here's the problem with Core XY. You have, and I'm even going to explode and delete this because we really just need to get rid of the plastic printed parts just to see this, okay? And this is the problem with all the claims that Core XY is the premier in space efficiency. It is not. Simply put, I don't agree with those people. I think they're wrong. So let's take a look at this. It works pretty good for the y-axis compared to most other designs. Particularly the problem with the Prusa type designs is that they effectively double the y-axis. So your print area, let's say, is 200. At the very minimum, the print bed has to go 200 millimeters all the way to the front and 200 millimeters all the way behind the back printing point, which means it effectively doubles. It effectively doubles the y-axis travel, which is very bad for a very large printer. So if you have a 300 millimeter printer, like the CR10, let's say, for example, where the y-axis bed, let's bring that up real quick. Here it is. So the y-axis bed on the, see this bed here? It moves all the way back. So when the printer's printing at the back, this bed has to move all the way to the front, which means your desk space that this thing takes up, the footprint of this printer is very large in the y-axis, extremely large, right? Because it has to double 300 plus a little bit extra for, just in case. So that's bad about these things. However, you can see that the MicroWrap, for example, I'm going to go with MicroWrap 100. Oops. Was one I made. And the reason that I chose not to go with Core XY for this printer was I was absolutely, the whole point of this printer was to make a tiny, compact 100 millimeter by 100 millimeter printer. Now, you might say, oh, that's way different than what he's doing. Yeah, you're absolutely right. But I want to point out something that's very important. Doubling 100 by 100 with a traditional moving bed means you're only adding 100 millimeters, or maybe a little bit more than that, to the total footprint of the printer. So you see, doubling a small number is not bad. Doubling a massive number like 300 adds another 300. Doubling a small number like 100 only adds 100 millimeters. And I would say that Core XY wastes more than that on the y-axis. So, but you can see it doesn't scale well. That moving bed design does not scale well up to larger beds on the y-axis. All right. So that's one thing that I'm going to give credit to the Core XY in terms of if you're making a large printer, it's pretty good for that, right? Okay. Because you're not wasting a whole lot of extra space. Now, let's look at the x-axis. So on MicroWrap 100, the x-axis, the whole printer, it would be, you take how much exactly, it's designed to be like 100 millimeters. It's going to add 100 and I think 2 to the external dimensions or something like that. Of course, there's material thickness to deal with, but it basically adds an extra 100 millimeters, okay? Whereas this printer right here, we already saw it was designed to do 300 by 300, and let's look at it. 480. 480. So whereas the MicroWrap 100 gets away with like 100, 102 extra, and hey man, to be fair, that is, well, and then they're not even enclosing it like MicroWrap is. So look, man, this is, it's a myth. It's a common myth that Core XY is a very space efficient design. We can see here, this is adding 180 extra millimeters. And 55 of that comes from, I think it's 55, a little bit more, yeah. About 55 comes from the width of the carriage. Like, that's not printable. Okay, you're wasting that much of the printer's width, and it's almost inevitable. You have to have some width to the carriage, right? Otherwise, it doesn't exist. But the thing that I do not like about it is, let's take a look at this. I'll move this over 150, 150. And so all of this extra rod is just being kind of wasted on the x-axis. Now I've cut some of that stuff away, and the reason this is because Core XY has this inherent flaw, or has this, it's not a flaw, it's just something that's true about it, and you have to work around and design around, is that, see this distance? No matter how you cut it, the carriage cannot travel past this point. Now there might be some clever ways to manipulate this, I'm not going to lie, but it cannot. And look at this. I don't care how you work around this and design your printer. Your printer is going to have extra width from here over to here, and then it comes tangent here and over to here and all the way out. So basically, essentially, no matter how clever you are in designing Core XY, you have this, look at this, 42 millimeters of space on this side out to the motor. Now, hey, I'm not going to lie, there might be a clever way that you could redesign these shafts, but it has a tremendous amount of wasted space on the x-axis. Not bad. And what do we get out of that? Well, it's worth it probably, because, look at this, we get a carriage that has no, we get X and Y actuation without moving any motors around. Both of these motors are stationary on the frame. So is it worth it? Probably. But this idea that people will constantly post about, and that you know better now, is that Core XY is very space efficient for the Y-axis, and it can be, depending on how it's implemented. It is not space efficient, I would say, for the X-axis. It's just not. There are better options. It's not bad, but there are better options. That's all I'm saying. So, hey man, if you stuck around for the end of that rant, I hope you learned something. If you disagree with me about Core XY or whatever, just leave it down in the comments, because, dude, this is what I'm into. I'm into building printers. If I'm wrong about something, or somebody wants to show me a better example, whatever, that's great. But, hey man, if you stuck around for this one, thank you for watching. And I'll be back next week, or maybe sometime earlier this week, and we will actually start building the Z-axis.